Just joking. Welcome to Thailand. Okay, for my talk, I'm gonna talk about microdots. So what exactly are microdots? So I'll be talking about how do you why microdots and how you can actually make them. And I have some samples, so after the talk, you can check it out. So I guess there's a lot of questions about OPSEC and how can you hide seed phrases? And so a lot of the processes are all digital, but what if they're physical processes if you can obfuscate stuff? And so key custody remains like a huge problem. And so there are like secret sharing, social recovery practices, but I know a lot of crypto people are incels like hikikomori, so like social recovery might be hard. So look at this graph. We have the homeless epidemic that is happening right now. So yeah, key custody and like social recovery is going to be a huge problem. So what if there are physical approaches of obfuscating information? And so this is one of a steganography technique, and it's called microdots. And so the reason why I'm showing out this Anya Forger today is because has historically been used in espionage and spies. And so the goal is to essentially hide messages in plain sight. So how do you do this? So apparently all the documentation around this is so limited. So you try asking Claude, it's like saying, sorry guys, no info for you. So I was like trying to reverse engineer this information myself, and basically the slides are gonna document everything. I won't be able to cover everything, but I'll cover through some interesting details. So we are gonna revive analog photography for this use case. So why we want analog processes? There's basically no chance for someone to hack like an analog camera unless he steals a camera from you. And there are a lot of gotchas, so I kind of screwed up so much, and I can't talk everything in details, but I'll create a GitHub repo documenting the processes. So one of the main issues with analog photography is this thing called ISO. So on your cameras, like this is not a huge deal, you can adjust it. But ISO is a function of like the film grains. And so this becomes a problem of how much you can miniaturize an image. So the smaller the ISO, the smaller the grains in general. And so this is like the few processes that you need to do. First, you need to take a photo, and then you have to develop a photo and then fix it. And that's like the first phase. And so we'll be talking about two phases. So the second phase is instead of expanding the image, we want to do the opposite. Okay, so these are all the things that you need to use. Oh yeah, so this is kind of interesting. So I have like two processors. One of them uses ammonium dichromate, so I call this cancer orange. So I probably need to go for cancer screening after this because I think I might have breathed in some dust from this. Yeah, and then there's like cellophane. So there's like dialysis tubing. So I was like going to a medical store. I don't have diabetes, by the way, but no, I don't have kidney failure or diabetes. But you need this to kind of as a substrate. Okay, a bunch of optic stuff. So this is how you do it. You write your seed phrase. So normally in MetaMask, you ask you to write a seed phrase, but then where do you put the seed phrase? So this is one way you can store the seed phrase. You take a photo of the seed phrase, roll in the film, develop the film. Oh, and also one interesting thing. Apparently, these are all heavy metals because they're silver metals. Like you shouldn't pour it in your toilet. So I accidentally poured some in my toilet, so I might have committed some offenses around here. Yeah, it will probably corrode my pipes in the worst case, but I might have caused some like environmental hazards. Yeah, so the next process, you take the photo again, and then ta-da, you have this tiny little boy over here. And so this process where you retake the photo again is called the British process. And the next other process which I want to do was like a dichromated process. And this is how you can get like microscopic minifications, like 1000x. And so the goal is to find a chemical substrate for this. And so this is where the forbidden orange juice comes in, and it's very toxic. Do not breathe in or use this chemical. So I'll try to find like a better chemical for this, but most of the photosensitive chemicals are toxic as hell. Yeah, and this is like the process. So I did spill some of it, and so I almost died. Yeah, and so this is how it works. You project the image, and then you get this tiny little thing, dots on this piece of paper. And that's it for this presentation. I'll share more details on the GitHub repo if you guys are interested.
Thank you, Jason. Very cute hair. Any questions? Okay, I'll do the easy one.
How do you do this whole process without getting on the FBI list?
I'm probably on the list right now. So I guess you need fake IDs or...
Got it.
Okay, another question.
Did you consider anything else?
Oh, I did consider like other steganography techniques, but I think things like microdots have historically been used, but I somehow do not see them around in practice today. So it could be the case that it's all classified. So I'm like, maybe you're leaking classified information right now. So.
Well, I guess my follow-up question to that is there were other methods used for espionage throughout the world wars that might have been easier to do.
Yeah, it might be classified. So yeah, I couldn't find much information about this, unfortunately. So I was just reverse engineering the chemistry. Yeah, instead of code, it's now chemistry.
I think we have a question at the back there.
So why are we not using photolithography for it?
For photolithography. Oh yeah, it's basically a similar technique. So, but not everyone has a clean room in their home. So the goal is to find processes that you can do in a home environment. So it's kind of similar to photolithography techniques. So some of like the techniques are applicable. Yeah, but also like photolithography, also some processes are patented, so you can actually like use them in practice.
Cool. Any other questions? There's one over there. Can we throw? Is it in the middle there? Oh, no. Sorry, you raised your hand, and I thought you want to catch up. Okay, there's another question there.
How small are the microdots?
I can show it to you later. It's quite small. That's all I can say. It's like small.
So you definitely need a microscope.
The one using the British process, you can see if you're with a naked eye. But the other one, it's kind of really damn tiny. So I'm not even sure whether it's like an actual image or not. Yeah, I need a microscope for this.
Great.
You do have a question.
And how long? Hi. And how long does it stay? Is there like a half-life?
Half-life, this is not radioactive.
But what I mean is like, does it? Can you see it after like 20 years, for instance?
We'll find out in 20 years.
Okay, one more question over there.
Okay.
Hello. Have you reversed the process, meaning you encoded? Have you blown up the picture to see if you can recover it?
I think you could. You probably need some kind of optical setup. So essentially, you're trying to project an image.
Okay, we're running out of time. That's the last question. Thank you very much, Jason.
If you guys want to see stuff, I'll be somewhere around here. You can see some of the samples. Thank you for your time, guys.
Thank you.